Let's check out this practice ACT or SAT practice problem together. If you'd like to try it on your own, go ahead and pause the video now, otherwise, let's go over it together. The figure shows the graph in the xy plane, which is this image over here, of the function f of x is equal to x squared plus 2x minus 8. That's this quadratic or parabola curve sketched down here. The question is, which of the following is an equivalent form of the function f that includes the coordinates of vertex v as constants in the function? Below to the left, these are our 4 options to choose from. And just so you're aware, vertex v is located at the bottom of the parabola at the minimum. Let's start by rewriting the function here. Recall that this is written in standard form for quadratics. That's this form right here. Because we're asked to rewrite this using the coordinates of the vertex, we're going to have to convert this standard form of the parabola into the vertex form. In case you forgot, this is vertex form. The strategy I'm going to use to convert this from standard form to vertex form is going to be called completing the square. When completing the square, we start by grouping our first 2 terms with x values and leave our constant alone. Then, inside the grouping, we're going to have to add some constant that's going to complete the square, but we're going to have to also subtract it on the outside to balance it out. So grouped inside the parentheses, we have our x terms of x squared plus 2x, and we're going to add some unknown constant for now, and then outside the grouping we have our minus 8, and since we added something inside, we're going to have to subtract that same thing on the outside. Because we're subtracting the same constant that we're adding, we're not really changing the function, we're just changing the way we're writing it. To figure out what constant to add to complete the square, we always take half of the b term, which is 2 in this case, and then we square it. Half of 2 is equal to 1, and 1 squared is equal to 1, so we're going to add 1 inside the parentheses, but we're also going to subtract 1 outside the parentheses to balance it out. Rewriting this and combining the constants on the outside, we're going to get the quantity of x squared plus 2x plus 1 minus 9. Looking inside the parentheses, hopefully this looks familiar that this is a perfect square trinomial. Because we completed the square, we can rewrite this as 2 identical binomials, or x plus 1 squared. From this, we know that in vertex form, this function is f of x is equal to the quantity of x plus 1 squared minus 9. Comparing this to the formula to the right, we know this plus 1 on the inside means that h is equal to negative 1, and this minus 9 on the outside means k is equal to negative 9. We call this form vertex form because the coordinates of h, k represent the vertex, so in this case our vertex is going to be located at negative 1, negative 9. And if you go ahead and look at our answer choices, answer choice A matches what we have perfectly. Hopefully that was a good little quick review on converting standard form to vertex form by completing the square. Even though we already have the answer, let me show you a slightly different way of going about this problem that could save you some time. Looking at the zeros, or the 2 x-intercepts, we have negative 4, 0 and 2, 0. It's helpful to know that parabolas are always symmetric, so if you know where the x-intercepts are, the vertex is always going to be halfway between them. Another way of thinking about that is that the x-coordinate of the vertex, or the axis of symmetry, is going to be the average of the 2 x-intercepts. If we average our 2 x-intercepts, or add negative 4 and 2 and divide by 2, we're going to get negative 1. This negative 1 is exactly halfway between negative 4 and positive 2. That means that for vertex form, h equals negative 1, or x equals negative 1 is the axis of symmetry, or the middle line for the parabola. Here's that imaginary vertical line, or axis of symmetry, drawn. So at this point we have the x-coordinate for the vertex, and to find out the y-coordinate, all we have to do is take the original function, switch x to negative 1, and solve it. From this, we can see that when x is equal to negative 1, then f of x, or f of negative 1, is equal to negative 9. And there you have an alternative method for finding out the coordinates of the vertex for this quadratic function. If you found this video helpful, please consider leaving a comment down below and help support this channel by liking the video as well. As always, keep up the great work, and I'll see you in the next one.